Right. Here in this question, the nucleus of an isotope of osmium contains 76 protons and 190 neutrons. Which of the following can be used to represent this isotope? So, what you should know is it's very simple. Here, this is the osmium or whatever you prefer. Right. Here, you will have what a number of nucleons over here. Number of nucleons means number of nucleons means number of protons plus number of neutrons. So here I'm going to use the hash mark, number of protons plus number of neutrons. Here you should have number of protons, right? So if you make it in this way, what you will get here, it's 76. You don't need to worry about that one. And here you will get what? 266 if you take the sum of 76 and 190. So the answer is A, right? In B, a car travels along a straight horizontal road. A drag force of 150 acts for 15 seconds, causing the speed of the car to decrease. Which of the following is a change in momentum of the car due to the drag force? Here we have to use the equation of impulse. So here the equation is F times T equals to change in momentum. Right, and here they have given 150 newtons for the force and time is 15 seconds. So what you will get for your momentum is 2250 kilograms meters per second. Right, here it is SI. I hope I have to change my pen. Yeah. Right, the tubes of a linear accelerator get progressively longer along the length of linear. Which of the following is the reason for this? So you can, I hope you can imagine the length of the tubes. They are like this. They are increasing little by little, right? At the end of the tube, you will get nearly equal length because they are approaching the speed of light, right? They're asking which of the following is the reason for this. The frequency of the applied potential difference decreases, wrong, right? It says the same. Frequency of the increases, no. The particles gain mass as they accelerate, no, that is not the case, right? The particles must spend same time in each tube. Yes, this is the reason, because they are increasing their speed up to near close to speed of light. So if they want to spend same time in each tube, right, same time in each tube, they should go much a better length or much longer length, right, than the previous one. So that's why we have to increase the lengths of these tubes when they got approached nearly closer to speed of light. You will have the same length. That's why at the end of the linac the lengths are nearly equal, right? Here, which of the following is a possible unit for magnetic flux? I hope you remember the equation for magnetic flux. It is B times A. So you measure magnetic field strength in Tesla T, right? A is square meters, so you will get the units of magnetic flux as Tesla square meters. So the answer is A, right? Here, in fifth one, which of the following is not a valid conclusion from Rutherford's alpha particle scattering experiments? The first one, the nucleus contains most of the mass of the atom. Yes, that is correct, right? The nucleus contains protons and neutrons. No, the Chadwick did the experiment about neutrons, not Rutherford. He just concluded nucleus is charged, right? That's what he concluded about the nucleus. And nucleus is very small compared with atom. That is also correct. And most of the atom is empty space. There are few conclusions, right? This is also correct. So the answer is B, the incorrect one. 6. A particle detector shows tracks produced by two particles X and Y. The particles created by the decay of kaon at O, right? So you can clearly see this particle is moving this way and this particle is moving this way. They are circulating. So the centripetal force acting towards this way due to the magnetic field and their charge, right? Due to the magnetic field and their charge. We don't know their charge and the magnetic fields, right? Which of the following can be concluded from the tracks, right? A magnetic field acts into the page. No, we can't tell it because we don't know the charge, so we cannot use our left hand rule for this one, so we can't tell it. X is positively charged particle. No, we don't even know that one, because if we don't know the magnetic field, we can't tell which particle is positive and which particle is negative, right? Y is an electron. No, we can't tell it, right? X and Y have opposite charges. Yes, they should have opposite charges, because um, if you place left hand rule for X, you can clearly see that they are moving toward this direction, and in Y they are moving towards this direction, so they should have opposite charges, right? Okay. Here, the diagram shows the path of two charged particles, X and Y, moving at the same speed in a uniform magnetic field, right? Which of the table describes the properties of Y compared with the properties of X? Right. I hope you remember this equation. If I just derived it, it is mv square over r for the centripetal force acting on the particle, and that is equal to what? The magnetic force due to the charge of the particle. It is bqv. So we will get a force for moving particles, and if we can cancel out this v over here with one v of here, and we have to subject r, and if you subject r, what you will get here is mv over bq. You can clearly see what r of y is smaller than r of x, right? If r of y is smaller than r of x, or r of x is greater than, the radius of x is greater than radius of y, what we can tell, right? uh, the mass of x should be greater than what? Mass of y, right? And relatively, what about the charge, right? Charge is inversely proportional to the radius. So if rx is greater, what we can tell about that one, the charge of x should be smaller than charge of y. Here they are asking mass of y and charge of y. So mass of y should be greater than, and mass of charge of y should be uh, mass of y should be less than, here should be less than, and charge of y should be greater than. So the answer is B, right? B. I hope you got my idea. uh, Here, a toy aeroplane is traveling in a circular path. The toy aeroplane completes 12 revolutions in 6 seconds. Which of the following gives the angular velocity in radians per second of the toy aeroplane? Right. How can we calculate that one? Right. Okay. If you want to get the angular velocity, right, you should, here it is, angular velocity, that is equal to what? Theta, right? Theta, right? Theta here. Theta means the angle that it has covered, or what we can tell about that one, or to get, right? Here, for whole circle, what you will get, the angle of 2 phi, right? The angle of 2 pi. Then it has covered 12 revolutions, so it is 2 pi times 12, right? So what is the time that it has taken for these 12 revolutions? It is only 6 seconds, right? Okay, because we all know omega is equal to theta over t. So the answer should be B, right? Yeah. In the ninth one, a capacitor discharges through a resistor. The time constant of the circuit is 5 seconds. What is the time taken in seconds for the charge on the plates of the capacitor to half? Right. I hope you remember the equation. Q equals Q naught e to the power minus T over RC, which we call time constant. Right. Here they have given the time constant. And if it is half, right, so what we can write from this equation, it is Q over Q naught equals min e to the power minus E over RC. Then if I make it into a natural log, right, you will get uh, ln q over ln q naught equals minus t over rc. I want to remove this minus sign, so if I multiply both sides by minus, what you will get here is ln q naught over ln q, right? Ln q equals t over rc, because here you can write ln q over ln q naught like this way, ln q minus ln q naught. So if you multiply it from minus, what you will get here, you will get plus, and here you will get minus, right? So you can write it like this way. So q naught is the initial value. It is 1. It is 0 point, you better write it like this way, right? Ln q naught over q, right, equals t over rc, right? Okay, here uh, q naught is the previous, so if it is 1, then q naught is 0 0.5. What you will get here is ln 2 equals t over rc. They have given rc, it is the time constant. If you replace it over here, it is 5 times ln 2, right? So the answer is D. You don't need to do this much of calculation for this question. If you are familiar with the equation, I just derived all these things by showing the all algebraic steps that you need to cover. But if you are comfortable or familiar with the steps, you don't need to spend this much time. Okay, here a car travels over a humpback bridge as shown. The bridge forms part of a circle of radius r. The car has mass m, travels with a constant speed v, right? Travels with a constant speed v. So I'm going to redraw it right here. This is the bridge, right? So what are the forces acting on the car, right? Centripetal force is provided by the resultant forces acting on the resultant forces acting towards the center of this path. So what are the forces acting on the car, right? Probably you know what. One is weight, right? And there will be a normal reaction from the bridge towards the car. So this is R, right? And this is mg. So if you write an equation for centripetal force, it will be mg minus r equals mv square over r. What they're asking here is which of the following expressions gives the force from the bridge on the moving car, right? From the bridge on the moving car. So they are talking about what? This uh, normal reaction, right? So I have to subject it. If you subject it, right, r will be equal to what? Mg minus mv square over r. So the answer should be C, right? Answer should be